Hello everyone. Let us continue the analysis of portal frame. In the last class, we have done one numerical problem on the portal frame. Let us continue with this one. So first open the Staad Pro software. So click on new project. So select the plane. Give the name as portal frame number 2. So I see the location and units. Click on next. Next click on add beam. Finish. So select the front view. So today let us solve this problem. So here first let me draw this is your y-axis, this x-axis, and this is the z-axis. Whatever the grid you are seeing, this is the grid. It is 0 at x-axis and y-axis. Z-axis it is towards you, which is unable to see. Only in the 3D you can see the z-axis. So this grid, so this is the origin. X-axis is 0 here and y-axis is 0 here. Your node has been started from here, not from the origin. So for the case, and here also the dimension is not uniform, not even. So first let us know the coordinates of all the nodes. So here the origin coordinate is 0 0, but here the node is not there. For your understanding, I'm mentioning this is 0 0, and a node x, for this one x is not there, that is 0. Y-axis, it is at a distance of 3 meter. So it is x is 0, y is 3 for this node. Next for B node, so x is 4, y is 1.5, 3. It is 4 comma 3. Next for D node, total x is 4 plus 1.5, that is 5.5. 5.5 comma y is 1.5 plus 1.5, it is at 3 meter. Next C, so it is at a x distance is 4 meter, y is not there for this one, so 4 comma 0. So you know the coordinates, you can easily mark the nodes. So either you can use this one snap node or you can close this one. So if you close this one, you will get to see the coordinates x-axis, y and z coordinates. So here the node is not there. The node has been started from here. That is x is 0, y is 3 and z is not there. Next, the second node, it is x is 4, y is 3. Next, third node is, this one is 5.5 and y is 3. Next, this node, x is 0, y is 0, x is 4, y is 0. Next, you can click on close. So that has been created the nodes. So these are the nodes. So if you click the grid, you can see the nodes. Here one node is there, here one, and here one node is there. Each of the grid. So now 4 nodes are there. Now let us create the beams. You choose the add beams here. Click on add beam. This is the starting point. Click this one and end the beam here for the node B. This is the starting point for the node for this beam, and this is the end for this beam. So click on this one, and or else you can click on this. So starting point here for this beam is here, and end point is here. Similarly, click here and end here. So we have created the nodes and the beams. So next step is you have to assign the property for the beams and the support condition for the nodes. So here, so he has given for this beam as moment of inertia I, for this one as I, and he has not mentioned for this one. So you can assume for this one also as I. Click on general, define, you can assign the cross section, or else you can go for the moment of inertia and you can assign the directly the moment of inertia. If you assign the same uniform cross section through the for all the beams, it will automatically get converted to the moment of inertia. I will give 0.4 by 0.35. So you know the moment of inertia for the rectangular beam is BDQ by 12. It will get automatically converted and it will assign the property. Or else you can choose the general. Okay, here still I have not added. Or else you can choose the general. You can give the moment of inertia by assuming any value 0.00001. I will assume meter raised to 4. The material is concrete. Click on add. Close. Now it is uniform for all the beam. So here beam cursor is there. So click here and select all the beams. Now assign to the selected beams. Yes. Now it has been assigned the same moment of inertia. Now click on close. Now you have to assign the support. Support at A and C are fixed and at D is not mentioned. At B it will automatically take fixed support. There is nothing to assign. So create fixed add. So click on the select the fixed support, use cursor, assign, click on node A and node C. It will take here. So it will take fixed condition here. This is there is no support at this D point. So the next step is you have to assign the loads. Click on loads and combination definitions, lowercase details, add, give the name lowercase one, add, close. Select the lowercase one, add. So this is the AB member. On the AB member, 2.4 kilonewton per meter load is acting the downward, that is minus 2.4, and this is 10 kilonewton acting exactly on the node D, and this 12 kilonewton it is acting on the member BC. So this is going left side, that is minus, this is along x-axis. So first let us assign this 2.4, that is member load. This is uniform force minus 2.4. It is acting over whole length, that is along global y-axis. Click on add. So this one is over. Next, this one, it is acting on the node D. So that is nodal load. Nodal load that is acting along y-axis minus 10 kilonewton. Click on add. Next, this is 12 kilonewton acting on the member. That is member load. Concentrated force it is. So this force is going left side. That is minus. It is minus 12. And for this beam, your beam has been started from here. So this is the D1. So this is the D1. So D1 is 1.5. So D1 is 1.5. It is acting along global X. Click on add, close. Use this one, use cursor to assign, click on this beam. Next, to assign the nodal load, you have to select the first this node. So use node cursor, select this node. Next, click on this one, use cursor to assign, click on this one. Now it has been assigned. Yes, this is concentrated load, global X minus 12, 1.5 meter distance. Use cursor, already assigning is there, click on this beam. Now all the loads are being assigned. Next, to view the loads, click on this one. The scale is very large. So you right click on this one, labels, load value. Next, scales, you will increase by 70.4. Close. Now you can see this one is 2.4 and this is minus 10, this is minus 12. Okay. So all the loads have been assigned. Next is step is analysis and print. So no print, click add, close. Next is analyze, run analysis, save. So zero error is there. Go to post processing mode, done. Select the load case one, okay. So this is the deflection button is on now. So I will first enable the automatic scaling. You click on the result setup. So here result view options, enable automatic scaling for shear and bending. Okay. If you click on the shear and bending, it will get automatic scale. But still the scale is very large. So you can reduce that one by using control button on the keyboard and the scroll down button in the mouse. So let us view the results, view value, beam results, ends and midpoint, annotate, close. So I will increase this one. So a little bit. So I'll use the pan to move the window. So this load is 15 kilonewton meter, and this point load is moment is 10.184 kilonewton meter. At this midpoint is 7.5 kilonewton meter. Here is 0, and this moment is 4.816. At this midpoint is 6.83, here 9.156, 0.289, 0.148. Let us verify the results. So here it is 15 is there. So it is 15 only. So at this point it is 10.184. Here 10.19 is there. At midpoint it is not there. You can do by interpolation and you can find. At D it is 0. You can see here. Next here it is 4.81 is there. Here it is 4.816 is there. And here it is midpoint is 6.83 is there. Here is 6.83. This is 9.156 is there. 9.16. And here it is at that the side node A 0.29 is there, 0.289 is there. Okay, at the midpoint here 0.418 is there, here 0.15 is there. So the results are verified, it is correct. So next, similarly, you can view the shear force Fy, that is the scale. So results, view value, beam results, one tip this one. Here it ends and midpoint, notate, close. Here you can view the deflection, results, view value, beam results, displacement, notate, close. So this is a hogging, and this is also this beam has moved upward. This is also hogging. This is also so to restrain this one, you have to provide the steel at the top for this one. So let us click all the buttons and we'll click all the view results values ends here ends midpoint annotate close. So first let us take the picture of the before that first we should take the modeling picture. This is the modeling picture. First click on the loads. Let us take the picture of this one. Edit, take picture number 1. Okay. So it has been captured. Next is click on the post processing mode. You get to see the results. Click all the results, shear force, bending moment, and the deflection button. Click on the results, view value. You tick all the results which you want to view. Annotate, close. Next, I will untick the shear force and deflection. Yeah, I will use the pan, or you can reduce the scale a little bit less. Now you can take the picture of this one. Edit, take picture number 2. Okay. So this is over. Next, I want shear force. Edit, picture number 3. Okay. Next, deflection. Take this one. Edit, take picture number 4. Okay. Next, file. You have to set up the report setup. If you want output files, that is whatever the beam results are there, you can get that one also. Beam maximum movements, if you want, you can get here beam maximum shear force. These are the output, the results you can view. Even the shear force, the reactions you want, all the results will be printed. And okay, on OK, file, export report, Word file, water frame number 2, save. So these are the results that will get printed automatically. So see here here the job information has been printed. The name you can give, date, and the type of structure, space frame. I think I have chosen space. Okay. And the loads are 2 loads, number of nodes, number of elements. Okay, next is primary load. Load case is only one. So the beam number 1, 2, 3 beams are there. Node 1, 2, 2, and the lengths are mentioned. Here the load conditions. Here the bending moments are there. Maximum positive 10 minus 0.2 like this. All the bending moments you will get here only. Similarly, this is the shear force of Y, and this is the reactions. Like this, you can print the report. So similarly, if you want the pictures of the uh, report, if you want the report of the pictures, you can select the report setup. Here, pictures. You can select pictures 1, 2, 3, 4. Next, here, whatever the results you want, you can click on here. You want the beam displacement details. If you want details, you can get here. Okay, let us only choose this much. Okay, next click on OK. Next, file, export report to Word file. So again, I will give the same name, save. It will ask for overwrite. Click on yes. Cancel. So now you can see the results. The pictures also has been get printed. So you can make changes and then you can save this one later. And afterwards, you can give the printout of this one. So now let us go for the next problem. So let us analyze this problem. Click on file, a new plane, give the name as portal frame number 3. See the units, click on next, click on add meme, finish. You want to save changes, yes, whatever the pictures that I have saved for the previous one. So select the front view. So the node has been started from here. So first let us know the coordinates. So draw the y-axis, this is x-axis, and this is z-axis. So this coordinate 0 0, and this coordinate x is not there for this one, y is 4. This one is 0 comma 4 for a node, y is 4 0, x is 0. Next for b node, x is 1 plus 2, total it is 3 meter, y is 4, x is 3, y is 4. Next for this node, total x length is 1 plus 2 3, 3 plus 4 is 7, x is 7, y is 4. Next for d node, so x 1 plus 2, x from here to here it is 3, y is not there, 0. So these are the nodes coordinates. So I will close this one. You can see the coordinates. So first coordinate is 0, x is 0, y is 4. Next, x coordinate is 3, y coordinate is 4. Next coordinate x is 7, y is 4. Next coordinate is x is 3, y is 0. You can close. So this is the nodes. So to view first, let us add the beams for this one. Select this one, add beams. Click on this one and end with this one node. Next, click on this one and end with this one. Yes, this is the click on this one. This is starting point for this one and end for this one. So let us view the dimension. Display close. This is 3 meter 4 and this is 4. See, this is 3, this is 4, and the vertical beam is 4. Three, four, four. So next is, this is moment of inertia is 2i. This is 2i and this is I. First, we will create the moment of inertia I. We will assume the moment of inertia I, and next you have to multiply 2 for that one. So click on general, define general. So you assume first for the moment of inertia I, that is value as 0.00001. I am assuming this value. Click on add. This is moment of inertia I. For 2i you multiply it by 2, so it becomes 0.0002. Click on add, close. So this is the this one moment of inertia I. Use cursor to assign. Click on this one. Next use this one. Click on this one. This one. This is R2. This is R1. Okay. Next is we have to assign the support. This is pinned, fixed, fixed. Create, fixed. Next create, pinned. Add. First select pinned. Use cursor. This is pinned. Next fixed support. Add this node and then this. So for this node, it will automatically take fixed condition. So this is 19 member load. It is acting on the member AB at a distance. So this is the starting point for the this beam. The D1 is 1 meter, and this is also member load, that is 60. That is acting on a minus 60. So next is loads and definition. Load case details. Add. Give the name is 1. Okay. Select load case 1. Add. Select member load. Uniform load is minus 60. Minus 60. So it is acting along global Y. Add. Next concentrated force. So it is acting also along y-axis at a distance d1 is 1 meter. It is minus 90. D1 is 1 meter global y-axis. Add, close. So this is minus 60 kilonewton per meter for this one, UDL. Then this one, select and assign for this one. Close. Next, To view the load values, right click, labels, load value. To increase the scales for 0.4, so increase by some 70, and for the moment already there, so can increase by 150. Okay. So still have to increase the scales for this one. I'll increase by 100 for the point load. Scales 1. So now we can see this is minus 90, minus 60. So the loads have been assigned now. So here on this beam there is no load. So now let us analyze this one. Analysis and print. No print, add, close. It is asking for perform analysis, analyze, run analysis, save. So zero error is there. Go to post processing mode. Done. So select the load case one. Okay. Automated reflex button is on. First, we will enable the automatic scaling. Results, view options, enable automatic scaling for shear and bending. Okay. So select the bending moment. Still the scale is very large. Use the control button in the keyboard and rotate the cursor. So let us view the results. Results, view value, beam results, ends, midpoint, notate, close. So maximize that a bit so that I can view the results correctly. So this is 63, this is 55. So this is 88, this is 44. Let us verify the results. So this is 88, this is 44, this is 64 is there, this one 63 point is there, this is 56, and this is 55.89, this is 0, it is 0 here, this is 38.67. So here it is not showing exactly on the node, but it is the value we are seeing, this one is at the midpoint. But this moment is at the load. There is no option here. Similarly for this one it is 4 here. So the results are correct. Like this we have to verify the results. So similarly we can use the shear force, deflection results, view value, beam results, click all the results which you want, annotate, close. So you can take the picture of these things. Edit. The bending moment picture is it is 1 now. Okay. So the deflection shear picture as edit, take picture. This is picture number 2. Deflection. Edit, take picture number 3. Okay. Next I want modeling picture. Loads. So use pawn and move it down. Now edit, take picture. This is number 4. Okay. So now we'll set up the report file, click on file, report setup, output files whichever you want, maximum, minimum, maximum shear force. Okay, reactions, if you want reactions you can take. So to view the reactions, click on reactions here. So you can see the reaction. Y is 41.36. Horizontal reaction is 1 minus 1.7. Similarly, horizontal reaction for this one is minus 1.28. Vertical reaction is 126. And you can take this picture also. Edit, take picture, the reaction. File, report setup, output files, output result, whichever you want. That is maximum shear force, reactions, beam and displacement. Okay. So first, which result you want, you choose that one. This one. Next, second one you want this one, or else you can move this one like this, down, move and up, down. Beam and displacement. Next is reactions. Okay, next I want pictures for the respective. So this is the picture of the model. This one. Next is, this is bending moment, this is shear force, this one is deflection, and this is reaction. So I will choose this one. I will move upward. This is the modeling figure. Next, for that one, maximum bending moment. So I will move this one. So this is the maximum bending moment picture. This is shear force. I will move this one beneath the shear force. This is displacement. So I will move this one beneath the displacement, and this is the reaction, and this is a picture of the reaction. So next, click on OK. Next is export the report to the Word file for portal number 3. Okay. So now you can see the job information and the problem. This is the modeling figure. For that modeling figure, you can see the bending moment results, and this is the bending moment diagram for that one. This is the shear force, and this is the shear force diagram. This is the displacement. This is displacement figure. And similarly, this is the reactions, and this is the reaction figure. So like this, you can save later. So now let us end the class.